to make when you design a bridge or a big skyscraper and so on. Another one. A shear force of 750 Newton is applied to one face of aluminum measuring 10 centimeter on a side. This is an aluminum block, and on the upper surface we apply a force of 750 Newton. And what is the area on which that force is applied? The surface of the aluminum is 10 centimeter, it's a cube actually, 10 centimeter on a side. That means the top surface area will be 10 centimeter multiplied by 10 centimeter, 0.1 meter times 0.1 meter. So the 750 Newton is acting on an area 0.1 meter times 0.1 meter. We can now calculate the stress, and the strain will be the tangent of the angle of deformation. If the top surface is displaced, this is called the displacement of the top surface, by a distance x, then tangent of angle phi will be x divided by 10. Isn't 10 the height? This is a cube of length 10 centimeter, width 10 centimeter, and height 10 centimeter. So if x is the displacement and 10 the height of the block, then tangent of angle phi is x divided by 10. We can leave this unit in centimeters so that x will also be in centimeters. Alright. We need to find what is the displacement relative to the opposite face. Now this is the face resting on the floor, and the top face got displaced. We need to find that displacement x. Okay, 750 Newton is applied on an area 0.1 meter times 0.1 meter, that is 0.01 meter squared. Therefore stress is force divided by area, that is 750 Newton divided by 0.01 meter squared is 7.5 times 10 to the 4 Newton per meter squared. You got the stress. What is the strain? Strain is tangent of the angle of deformation. Shear strain is tangent of angle phi. And what is tangent of angle phi? Opposite side divided by the adjacent side, x divided by 0.1. Well, this is aluminum, and what is the shear modulus of aluminum? Can you look back on the table and get the value of the shear modulus of aluminum? You have S equal to 2.4 times 10 to the 10 Newton per meter squared. So we know the shear modulus for aluminum, we know the stress, and we know the strain where we need to find this x. So we can now say the shear modulus equal to shear stress divided by shear strain. There you are. That means 2.4 times 10 to the 10 equal to stress is 7.5 times 10 to the 4 divided by strain is x over 0.1. Okay, can you give me what x equal to in this case? If you understood the way we solved for delta L in the previous problem, you can tell me how to solve for x here. You can see this 0.1 will go up. And if you want to solve for x, this x can be taken to the left and this quantity can be brought to the denominator. So my numerator will be 7.5 times 10 to the 4 times 0.1, and the denominator will be 2.4 times 10 to the 10. So x equal to 7.5 times 10 to the 4 Newton per meter squared multiplied by 0.1 divided by 2.4 times 10 to the 10. And that will be 3.13 times 10 to the negative 7 meter. And that will be the displacement of the top face of the aluminum cube when this force is applied. I will now stop this part of the lesson here, and I will give you a second part of the lesson where we mostly discuss the concept of pressure. Alright, I will get back to you with that lesson shortly.